Hello, everybody. Welcome, and thank you for taking the time to come and learn about AI and machine learning. My name is Khalid Salama. I'm a machine learning specialist in the Google Cloud team. And I came all the way from London to your beautiful city, Istanbul, to give you an overview about machine learning in Google Cloud. All right? I cannot talk about machine learning and AI without mentioning data, because data is everything. The degree of success is determined by how well you use your data. And it's very easy to know why. If you have shared, well-organized data, you will have access to useful information, you will be able to extract insights, perform analytics and predictions, and based on these predictions, you will be able to make optimized, timely decisions. Well, talking about data, Google's mission is to organize world's information and make it accessible and useful to everybody. It's a challenging task, and we've been doing this for decades. When you think about Google, you probably think about this simple text box for search, right? However, when I think about Google, I think about all the infrastructure, servers, hardware, data centers that enable us to carry such a planet-scale data and information management task. Not only that, this infrastructure enables us to serve solutions, services, and applications to users all around the globe. At Google, we have 7 products that serves 1 billion users each. You can imagine the scale. This is that platform that runs GCP, Google Cloud Platform. Our innovation is not only on the hardware level, but also on software level. Our research has led to born of many key technologies that transform the way people process and analyze their data. That include MapReduce, include HBase from Bigtable, includes TensorFlow, Apache Beam, Kubernetes, and many other. But in addition to organizing the world's information, we want to help our customers to organize their own information and make it accessible and useful for their business. And that's why we have many clients that we work together with different success stories in many domains, including Ocado in retail, AXA in insurance, Airbus in defense and space, HSBC, Rolls-Royce in intelligent chips, and many others. But how we do that? We do that by advanced analytics and machine learning. At Google, we believe that machine learning is core transformative tool that helps you to run and optimize your business. And this is why we made it clear in 2016, our CEO, Sundar Pichai, has declared it that we're moving from mobile-first to AI-first world. AI and machine learning is not new to Google. In search, the third most important signal for search ranking comes from machine learning. In Gmail, smart replies and spam filters, search voices via Google Assistant and Google Home, Google Translate, Google Search Photos, and many other products. All of our products and services are infused by machine learning and AI. It is in our DNA. Not only in our products and services, we also use machine learning in order to optimize the way we operate our systems. With the help of our friends in DeepMind, we applied machine learning in order to achieve 40% reduction in cooling energy at our own data centers. But why are we talking about machine learning now? Well, today we have all the ingredients that help building successful machine learning solutions. We've accumulated lots of data from our customer interaction with our systems. We have advanced a lot of algorithms, especially in the field of deep learning, and we have access to lots of compute in low cost. But when you talk about lots of data and lots of compute, you straight away think about cloud platform. The cloud platform is the best place where you can host your machine learning workloads. You can virtually store endless amount of data, and you can virtually use infinite number of compute. This is why machine learning loves the cloud. All right, when it comes to talk about machine learning on GCP, I'd like to talk about a couple of trends that we're thinking about. First of all, we want to set machine learning to transform all the industries and businesses and deliver business value. And in order to achieve that, we're working on 2 different fronts. The first front is to democratize AI and make it accessible and useful, not only for data scientists and machine learning engineers, but also for business analysts and business users and data users. The second front is that we're building specialized hardware for deep learning so that we enable hardcore data scientists, machine learning engineer and researcher to build their cutting-edge models and train them in hours instead of days and weeks. And in order to enable that, we set cloud to be the managed platform in order to run machine learning workload at scale. I realize that this is squashed a bit. All right. So cloud as the managed platform for machine learning. So let's talk a little bit about democratization of AI. It has a lot of threads related to it. First, we have a set of pre-trained machine learning APIs that helps you to make sense of unstructured data. That means you can use these ML APIs in order to extract objects, faces, location from images, entities, sentiment for text, and other more. We also want to help the automation of machine learning to build custom versions of these models to be trained and tuned into your own data. I'm going to talk about this when we mention AutoML. The third thread is the commoditization of machine learning. We're keeping on implementing more high-level APIs in TensorFlow so that data scientists can use them and apply them straight away into their data without implementing the algorithms from scratch. And the fourth thread is we're implementing SQL-centric machine learning functionality into BigQuery so people from SQL background will be able to apply machine learning to train models and predict and apply the models in order to predict data and outputs on the data using the SQL script. And this will be part of BigQuery. So why AutoML? AutoML would need no ML expert in order to build machine learning models. What you need to do is to prepare labeled dataset, upload it to your Google Cloud platform, and make use of the custom models to train this model and tune this model and deploy an ML API on your project and make use of it. Custom models trained on your data with Google's algorithms. It's fully managed on the cloud with code-free experience, only graphical user interface. State-of-the-art performance as well as model quality. Just under the hood of AutoML, what kind of things that we use? We use learn-to-learn techniques, meta-learning, transfer learning. We're transferring the optimized weights from our own pre-trained models in order to tune your own models, and we use techniques around hyperparameter tuning. The technology that most of the people would think that's going to be available in 5 years' time, we have it now at Google. Just to reference one of the customers that used one of our AutoML products, which is Vision Custom Model, Disney has managed to tag and annotate their products via their characters in order to provide a better search experience to the user in their product catalog. On the other front, building specialized hardware, as Alan Kay, a well-recognized data scientist, said, people who are really serious about their software, they need to build their own hardware, and this is what we're doing for deep learning. Google has designed tensor processing units, or TPUs, cloud TPUs. They are custom application-specific integrated circuit optimized for TensorFlow workloads. It gives you up to 180 teraflops, which means up to 15 to 30 times faster than contemporary CPUs and GPUs. So why TPUs? TPUs give you excellent performance with respect to money, training days instead of weeks, or hours instead of days, and is fully managed on the cloud. Just to give you an idea what it means to use a TPU, training a large-scale machine learning translation model took 24 hours using 32 GPUs, 1.5 hours using 32 TPUs. AlphaGo Zero, developed by DeepMind, Google's DeepMind, is also powered by TPUs. Just to put this in perspective and show you the big picture of our machine learning capabilities, you can run Spark ML workloads using Dataproc. You can run, train, tune, serve TensorFlow models at scale using Cloud Machine Learning Engine, which is our serverless, no operation service for machine learning. Or you can use machine learning or train and tune machine learning using Kubeflow on Kubernetes. On top of that, you can use you can use our AutoML capabilities in order to train our model using your data. Or you can make use of one of our pre-trained models in order to extract information from unstructured data and enrich your data sets. You can use BQML or the SQL-centric capabilities into BigQuery. You can also use Dialogflow in order to build chatbots and conversational apps. And you can use Data Lab as your integrated data science environment in order to perform exploratory data analysis at scale. And not only that, GCP has an integrated, complete data analytics ecosystem that allows you to do everything in order to build an operational machine learning system at scale. That includes capturing and ingesting data, processing and preparing data, analyzing and enriching data, serving and storing information, performing analytics and machine learning, as well as visualizing and performing collaboration. All right? So actually, I took less than 15 minutes. Thank you so much for your time, and hope it was useful, and I hope you enjoy the rest of the day. Thank you.